Hey there, science fans. Have you ever seen a magnet fall in slow motion? No, it's not a magic trick. It's the amazing world of science in action. Today, we're diving into the curious case of why magnets take their sweet time falling through copper pipes. Get ready for some electrifying fun. Imagine this. You drop a magnet into a copper pipe. You expect it to fall straight through, right? But instead, it descends gracefully, as if taking a leisurely stroll. What's the secret behind this gravity-defying act? Let's unravel this mystery together. Before we solve the mystery, let's meet our stars. Magnets and copper. Magnets are like the cool kids in school, always attracting attention with their magnetic fields. These fields are invisible forces that surround the magnet, pulling in metallic objects like iron. Copper, on the other hand, is an excellent conductor of electricity. Think of it as a highway for tiny particles called electrons to zoom around freely. But what happens when these two powerhouses collide? That's where the real fun begins. When a magnet falls through a copper pipe, something amazing occurs. The magnet's magnetic field, always on the move, interacts with the copper. This interaction isn't exactly a friendly handshake. It's more like a cosmic dance-off. As the magnet moves, it disrupts the peaceful flow of electrons in the copper. This disruption creates tiny, swirling currents of electricity within the copper itself. These currents are our next special guests: eddy currents. Imagine dropping a pebble into a still pond. What happens? Ripples, right? Eddy currents are like those ripples, except they're made of electricity. They flow in circular patterns within the copper like tiny whirlpools. But these whirlpools aren't just for show, they have a secret weapon. These eddy currents, as it turns out, are little fighters. They don't like change and they're not afraid to resist it. So when the falling magnet tries to change the magnetic environment inside the copper, the eddy currents step up to the plate. Section 5. Lenz's Law Fighting Back. In this section, we dive deep into the fascinating world of electromagnetism and explore how Lenz's law plays a crucial role in our understanding of physics. Here's where Lenz's law enters the scene, named after the brilliant physicist Emil Lenz. Emil Lenz was a pioneer in the field of electromagnetism, and his contributions have been fundamental in shaping modern physics. This law tells us that eddy currents always flow in a direction that opposes the change that created them. Eddy currents are loops of electrical current induced within conductors by a changing magnetic field in the conductor. Think of it like this. If you push on a swing, it swings back, right? The swing's motion is a simple analogy to understand how eddy currents work. When you push the swing, it moves forward, but it also comes back due to the forces acting on it. Eddy currents are like that swing, pushing back against the falling magnet's magnetic field. When a magnet falls through a copper tube, it induces these currents in the copper, which in turn create their own magnetic field. This pushback creates a magnetic field that opposes the magnet's own field. The interaction between the magnet's field and the induced field from the eddy currents results in a force that resists the motion of the magnet. It's like an invisible force field, slowing down the magnet's descent. This phenomenon can be observed in various demonstrations, such as a magnet falling slowly through a copper pipe, or even levitating above a superconducting surface. The stronger the magnet and the faster it falls, the stronger the eddy currents and the slower it goes. This is because the induced currents generate a greater opposing magnetic field, which exerts a larger force on the falling magnet, effectively slowing it down. Understanding Lenz's law is essential for grasping the principles of electromagnetism and its applications in real-world scenarios. From electric generators to magnetic braking systems, Lenz's law is at the heart of many technological advancements. So next time you see a piece of technology that relies on electromagnetism, remember the fundamental principles of Lenz's law that make it all possible. It's a testament to the brilliance of Emil Lenz and the power of scientific discovery. Section 6. Real-world magic. It's not just a trick. Now, you might be thinking, that's cool, Bill, but what good are slow-falling magnets in the real world? Well, let me tell you, the applications are more fascinating and practical than you might initially think. Hold on to your hats because this phenomenon isn't just a neat science trick. It has practical applications that'll blow your mind. The slow-falling magnet is a gateway to understanding a range of technologies that impact our daily lives. One amazing application is magnetic braking. This technology is used in various forms of transportation and machinery to provide smooth, reliable, and maintenance-free braking. Imagine a roller coaster hurtling towards a stop. The thrill of the ride is matched by the precision of its braking system. Instead of using traditional brakes, some roller coasters use magnets and copper fins to slow down. This method is not only efficient but also reduces wear and tear on the mechanical parts. As the coaster passes by, eddy currents are induced in the fins, creating a braking force without any physical contact. How cool is that? This means less maintenance and a smoother ride for thrill seekers. But it doesn't stop there. Magnetic braking is also used in high-speed trains, providing a safe and efficient way to decelerate from incredible speeds. Even wind turbines use magnetic braking systems to control the speed of the blades, ensuring they don't spin too fast and cause damage. And let's not forget medical technology. MRI machines use powerful magnets to create detailed images of the human body, revolutionizing the way we diagnose and treat illnesses. Magnetic levitation, or maglev, is another fascinating application. From maglev trains that float above the tracks to innovative gadgets, the possibilities are endless. So, the next time you see a magnet falling slowly through a copper tube, remember, it's not just a trick. It's a glimpse into the incredible world of magnetic technology that shapes our modern lives. Section 7. Magnetic levitation trains. Whoosh! But wait, there's more. This phenomenon also paves the way for superfast transportation magnetic levitation trains, or maglev trains for short. These futuristic trains use powerful magnets to levitate above the track, eliminating friction and allowing them to reach incredible speeds. Maglev trains use a similar principle to our falling magnet. By creating opposing magnetic fields between the train and the track, they generate lift and propulsion. This technology is still under development, but it has the potential to revolutionize high-speed travel. Section 8. Summary, the short and sweet of it. So, there you have it. The intriguing phenomenon of a magnet falling slowly through a copper pipe is not just a simple trick, but a demonstration of some profound scientific principles. The mystery of the slow-falling magnet boils down to a fascinating interplay of magnetism, electricity, and a little law called Lenz's law. This law is a fundamental principle in electromagnetism, discovered by the German physicist Heinrich Lenz in 1834. When a magnet falls through a copper pipe, it creates eddy currents, which are loops of electrical current induced within the conductor by a changing magnetic field. These eddy currents generate their own magnetic fields, which, according to Lenz's law, oppose the motion of the magnet. This opposition creates a braking effect, slowing down the magnet's descent. This phenomenon has real-world applications in magnetic braking systems, which are used in various industries to provide smooth and efficient braking without physical contact. It even paves the way for futuristic maglev trains. These trains use powerful magnets to levitate above the tracks, reducing friction and allowing for incredibly high speeds and energy efficiency. Who knew that a simple experiment with a magnet and a copper pipe could unlock such amazing possibilities? This experiment is not only a fun and engaging way to learn about physics, but also a gateway to understanding advanced technological applications. Science is full of surprises, so keep those curious minds exploring. Whether you're a budding scientist or just someone with a thirst for knowledge, there's always something new to discover. So grab a magnet, find a copper pipe, and see the magic of science unfold right before your eyes.